It gives me great pleasure to welcome and introduce Professor S.P. Singh. Dr. S.P. Singh has had an extremely distinguished academic career and continues to be very active in research, conservation, and action at the grassroots level. He had more than 30 years of service in the botany department of Kumaon University in Nainital, went on to serve as the Vice Chancellor of Gadwal University, and is currently chair of two NGOs, both working in the Himalayas, Cedar and Chia. He is also the coordinator for a multiple institute project looking at timberline responses to climate change. And I was just chatting to him in his more than 40 years of professional career. The way he likes to describe himself is a forest ecologist who's worked right across the Himalayas. He also has connections to many international institutions, including ICIMOD. He served in the policy space, working as part of the Planning Commission of Uttarakhand State Government. He is served as Chair of Excellence on Biodiversity and Ecology in FRI, and is currently part of Government of India initiatives on climate change and the National Commission on Himalayan Ecosystems. Ladies and gentlemen, put your hands together to welcome Professor S.P. Singh.
Thank you so much, Ravi, for so many kind words. In fact, it is really, I'm quite excited that I have to address, so many young people at one place. I consider it a great privilege to be with so many young people who are interested in science. I'm concerned about, the way, world is being managed. I see that the science is a problem because of so many other forces which are against, which are not doing science or evidence-based knowledge, I call it. So you are not only conservationists, you are also making a major contribution to the science, and by doing so, you are trying to support what you call knowledge-based or evidence-based knowledge, something like that. So I look at, I was telling Ravi that there is a book recently, Nobel Prize, and they say that one of the arguments about, Nobel Prize is that luckily there were about 7 or 8 great physicists in 1920s, 30s. You know Einstein very well, Dirac and others, Schrödinger and all those people. They gave value to Nobel Prize. In fact, Nobel Prize became important because of some scientists. So science has and then the whole world changed. What they did was the fundamental science. I'm saying, if you know that Nobel Prize is given only for fundamental science, but the contribution of that basic science was so great that it changed the whole world, and the world became very different from what it used to be in those days. So my present topic is Himalaya, changes in relation to climate. And you know that the Himalaya is important. I say that President of America, the most important person, should have said something about Himalaya. I have not heard him saying anything about Himalaya. It's a great feature, one of the greatest geoecological features on the face of Earth. From ecology point of view or from conservation other point of view, it provides so many systems. And you know that to do good science, you need two things, right questions and appropriate systems. Himalaya provides those systems, that's one angle. But also one of the problems is that it's the young mountains, they're very young mountains. They're susceptible to landslides or all kinds of disasters, even if there is no human being. I'm saying that should be always kept in mind. And people say that, some of you must be knowing that if the process continues, it is still rising, then half of India would be under Himalaya after some millions of years, something like that. Some calculations are that. So it's young mountains. They're still rising, and that's a really problem. And combined with the uncertainty of climate change, it can be quite scary. It's a maker of India's, say North India at least, or say the subcontinent of India, some people say, of the climate of those, say what you call monsoon. The monsoon arrival and Himalayas rise, they coincided. So people see connections between these two things. You can see, but another problem about Himalaya is that it's not one thing, it's not monolith. It's highly heterogeneous. You have a rainfall which is something easily 500 millimeter, 1000 millimeter, much more than any part of the world. And then you have some of the biggest rain shadow areas where you don't find any rain, say Tibet Plateau and all those things, or they call it trans-Himalayan regions. So I'm saying the problem with this heterogeneity is that you do some science and then try to project it and say that you apply to Himalaya and then you create problems. It happened many times. Say, if you remember Glaciers story, that some people predicted that after 30, 40 years, all glaciers would disappear. That was based on, say, a small sample. So Himalaya means a team science. I'm presently interested in this kind of science, means where several groups are involved, and then they call it multisite, multi-partner sciences. So that kind of science would be required if you really want to address Himalayan questions. Otherwise, you create controversies. And Himalaya has suffered a lot because of these kind of controversies. We call it water tower because we call it third pole also. Chinese have preferred this word, coined this word third pole because they think that it accounts for more snow it has than the rest of, say, outside these two poles. So it should be called third pole. And your interest is biodiversity. Say we estimate about 10,000 species in Himalaya alone. Hindu Kush Himalaya, they claim. ECMOD claims something about 20,000 species, something like that. And the ecosystem services all these years, I don't know whether you know ECMOD based at Kathmandu, they have been talking about Himalaya and they have now planned to say, use different forums to describe the importance of Himalaya at the global level. And climate change and all these things have become, say, related to this. So some 1 billion people, normally we say it, I would say we have to prove these things, science, it's not, say, all substantiate, but generally people believe that some 1 billion people get benefits because of Himalaya. This is one of the, say, photographs which I always like to show that some 10 river basins originate from Hindu Kush Himalaya. And in those river basins, some 1.3 billion people live. So that's really important to Himalaya that way. That's why we say tower, the water tower, or third pole, or the originator of civilization, we say. And then it's a very diverse, not only plants, but also culture, languages, and so on. Some 1,000 dialects, more than 1,000 something Eastern Himalaya alone, they say, are spoken. So it's a huge system from culture point of view, then biodiversity, then physical power of Himalaya, the energy it keeps on releasing, so that's where landslides and all those. And then associated with the most populated part of the world, a Gangetic Plain. So it's an unusual combination of wilderness and most populated part of the world, where 1,000 people living per kilometer is quite common. And we say one of the exercises with Rajesh Thadani, my one colleague, we did was that we showed that this much rupees services flow to, say, Gangetic Plain and other areas from Himalayan states. These are values of different Himalayan states. It's not exactly the values, but they are simply indicator of the, say, services which flow from Himalaya to, say, plains in terms of soil, water, and buildup. I'm saying, if you look at Gangetic Plain, you never hear terms like erosion, though agriculture has been there for the last 10,000 years, simply because there's a continuous replenishment of soil, water table, and all those things. We seldom value them. So many Himalayan states are talking about that they should be given some support that way. I will come to those points later on. And the real problem is that Himalaya is warming far more than people had predicted. It's 2 or 3 times than the global average. Everybody says that 2 degrees Celsius or 1.5 degrees Celsius is going to be dangerous limit. Himalaya has already exceeded that. So we are in that danger zone already. Means some people say Tibet plateau, it can be 4 or 5 degrees Celsius temperature rise. Some data may be not reliable, but general feeling is that Himalaya has been warming a bit too rapidly. It's a really matter of concern. And the warming rate is, there's a science of it. The extent of warming increases as you go higher. It's an elevation dependent warming because of some factors. And then as far as it's more with the, say, time, means if you look at data, say for 100 years, so during recent 3 or 4 decades, the warming has been twice as much in the earlier decades. Then you have a precipitation, which we predicted. Say, we means scientists predict that it is going to be more than, say, it has been or maybe stable. But what we have watched during, say, last 3 or 4 decades is that it is dying. I'm saying there has been less rainfall. Monsoon has weakened. Chinese researchers of third pole show that monsoon has become weaker and the westerlies have become stronger, and that's why you find difference in glaciers. I will come to this point just now. So I told you that the glaciers, the extent of rise of temperature increases with altitude. That's why the areas where glaciers are located are warmer than others. It's because of, there are some reasons. One of them is very commonly associated with this, that there are more pollutants in the lower parts. So that has a cooling effect. And in case of higher parts, you have less pollutions. But glaciers are melting, so albedo is, say, declining. So warming has become faster in the higher parts. This is one of the arguments. I would say I would focus on 2 points. I'm saying this is my hypothesis. I don't know. I will try to give you evidences about these. One is that, say, we talk about monsoon a lot, that what is happening to monsoon. But there's a period called pre-monsoon, means just before monsoon, which is very critical as far as drought is concerned. So what we thought that when temperature rise takes place in Himalaya, things should become better. Things should be, means the plants should grow faster or more growth. But associated with this warming is that is drought, especially pre-monsoon drought, March, April, May. And that has become intensified during last 10 or 20 years, something like that. And it has a lot of meaning. I will come to this point. So pre-monsoon is a critical change issue. That's the most important climate change issue, I thought, as far as Himalaya and surrounding areas is concerned. Here are some data you can see that say this is based on a published paper in Science, which shows that if you look what is the scenario of, say, glaciers. Out of 75 studies made, they show that 63 clearly show that the glaciers are shrinking. The other point is that you are seeing growth in some 12, which are in the Karakoram region. But the important point is that these data are more reliable than these data. I'm saying science of measuring glaciers is also complicated. You use different kinds. And reliability factor was considered in this one. Means mass balance is much more reliable than, say, glacier tip. Simply saying that glaciers are retreating because tip has changed. No, that's much less reliable. So they say that all the data which show glaciers are swelling are less reliable as far as research quality is concerned. But anyway, the overall scenario is that we are going to lose many glaciers. The causes I told you, that the causes are not only, say, remember that it's not only temperature. It's also moisture. After all, snow is also a form of moisture. It's a water. So when westerlies become stronger, that possibly explains why Karakoram glaciers are thicker, or they are not depleting. Monsoon became, say, weaker in the last 30 years, so moisture became a limiting factor. So let's hope that I'm saying all is not lost, and let's hope that if predictions of scientists are going to be correct, means monsoon is going to be strengthened, then let's hope that maybe the glaciers to some extent may revive. That's the science part. And then other point is that how much we are going to lose because of the glaciers. I'm saying how much we are going to how much glaciers contribute to rivers. Pakistan is going to suffer a lot. This Indus depends about 60% on snow or glaciers, whereas Ganga, Brahmaputra, our rivers are things are not going to be that scary. Maybe not more than 20%. Most probably not more than 20%. The calculations can be very difficult to make. These are all not reliable data, believe me. I'm saying Nepal people are also measuring that how much their catchments provide water to Ganga. We also do, and these values are different. So my point is that a river discharge calculations are less reliable, but overall scenario is that perhaps we are not losing these rivers. Rivers would exist. So it's not all disaster, which people predict. It's not correct. The other part of, I showed in that slide that how to retain water, or how to manage water. Because in monsoons, one of the problems of monsoon is that you get a lot of water only during a very short period. And climate change predictions are that you are going to have fewer days and more water. Means on a given day you are going to have a lot of water. So that's one of the issues which we need to address, how to really deal with this situation. They say that light rains have gone. And so there are fewer light rains than they used to. Light rains were more useful for plant growth and all those factors. So you can have a scenario like this. One Kedarnath is enough to affect for 4 or 5 years in economic terms, tourism and all those things. Still, I've seen people who are struggling with that event and coping up with the revival and all those processes. Bridges are not still in shape, placed again. So one calamity, that's really one of the biggest issues. That's why Amitabh Ghosh says that, I don't know why everybody is not talking about climate change, because he says that such events can be, the impact can be very serious and everlasting. So this is how to retain, how to manage water when we have a lot of water. And the other point is that how to retain water during the rest of the 8 months. Himalayan people depend on, springs for their, day-to-day water needs, not actually on rivers. I don't know whether you know Mussoorie still entirely depends on a spring. So these data show that we sampled about 45 cities, and we showed that almost all depend to some extent on spring water. 17 entirely depend on spring water, and there are some other combinations. The problem is that the springs are getting dried by the time, especially during March, April, May, the pre-monsoon. So pre-monsoon, even if the rainfall has not declined, in Himalaya pre-monsoon has become drier than it used to be, and then temperature rise is highest during that period, so evapotranspiration loss is much bigger. So you are going to have a water scarcity, and we are saying that the Himalayas should have more tourists. We never thought that there should be some control on tourism, but still we are saying that we need more tourists. If you say that let's have fewer tourists, then everybody would raise hue and cry. So the issue is that how to manage these things. Sometimes the water, when the tourism is highest, what is the scarcest. Less water means more fire. I will show next diagram that the fire intensity or extent of fire, which is man-made, but the situation is created by forest plus the climate change, is getting more and more, and it's dependent on whether when you have a rainfall during pre-monsoon, the fire intensity, fire spread is much less. So fire is also related to that, and then fire and spring, they can be, again the problem. The issue is that what should we do? And pre-monsoon warming and reduced pre-monsoon precipitation is one of the factors. So we need to have a realistic assessment of how to provide water in, Himalaya to what extent springs can play a role. There are some researchers like Tambe who have shown that it's possible to treat watersheds. And I think spring is related to wildlife also. The amount of water and all those things. Last fire, about 2 years ago, there was more mortalities of animals, wild animals, than largely because of the fire plus the lack of water in mountains, lack of water in the forest. They say that many animals were seen dying simply because there was no water in the springs or anywhere. So this period is going to be very serious in that way. So what should be, suppose we treat springs and make, it will contribute to some rise in water, maybe output may be 20%. But there can be many more advantages. I'm saying, can we have more co-benefits of spring revival, means for watershed treatment, more spring, more life, more plants, and maybe more wildlife. Can we really also include those things as the ecosystem services and justify, say, spring conservation? Because it's quite possible that spring conservation may not be, say, supportable on account of simply more water, because water may be only 20%, and that may not really satisfy the needs of the people. So if there is no spring, then what? I'm saying all this need to be planned instead of, I don't know, you are not familiar with the place like Nainital or Mussoorie. They have become a kind of extension of Delhi, I call it. Every weekend you can find some 1 or 2 lakhs people in Nainital simply because Delhi has become more boring. Nainital has deteriorated, but the plains are much more deteriorated, so the gap is still there. So people have more money, more cars, and all those things, and then more tourism. So in last year, what Nainital saw is it's a good place. It's one of the most beautiful spots if you look at, say, small spot anywhere in the world. But what happened to Lake Nainital simply because of say more water consumption? Earlier, it used to be summertime, say, tourism. Now it is say throughout the year weekend tourism. So you have more pressure. So last year, what happened that about 18 water level declined by 18 feet. 6 meters, I'm saying, level of the lake. And this was the situation, it is getting common. I'm saying this is happening for last 5-6 years. And then another problem was this, say, not say, giving regard to science. There's a place called Sukhatal. It's called Sukhatal. Sukhatal means it's kind of valley fill. It gets water and then gradually used to release water to Lake Nainital. According to some NIH estimates, National Institute of Hydrology, some 40% of subsurface water of Nainital is from this lake. This valley fill, that's called, it's a kind of spring water recharge, that way you can say. So, and we made an appeal that, look here, this should be declared like a small sanctuary. But what happened that people have a dumping place, they convert into dumping place. Ultimately, High Court and all those people have to really join hands. This is another issue. The government of India always says that what use of what you do and then what is the use of what you do to scientists, I'm saying. Now here's a simple case that where we provided useful science. We may not be doing good science every time, but it was not paid any, say, no attention was paid to this, and still things are, we are doubtful whether this High Court would be able to really, and say, really implement all those things directly without the interest of the government. So these things are happening. I'm saying managing a lake was the issue of climate change, partly because of the, say, what you call the behavior of the governments or governance, all those issues. I'm saying my job is to give an overview. So people are finding problem with the apple cultivation. I don't know whether you know it or not. Himachal's apple cultivation is one of the major success stories, they say, in which government was involved. The then Chief Minister took initiatives. And because of that, they could establish apple cultivation in Himachal. In Himachal, some more than, say, 100,000 people, farmers become rich because of apple cultivation. Now, apple cultivation is affected by climate change. You look at, say, the traditional valleys where apple used to be cultivated. It's the contribution of apple cultivation is to the economy is declining. and it is in Lahore Spiti, the colder areas, it is increasing. The problem with apple is that it requires a certain level of chilling, something about 1200 hours of chilling it requires. So that chilling temperature is no more available at the sites in, say, Kulu and Shimla, plus uncertain rain, plus diseases associated with the warmer temperatures. All these things have started affecting apple cultivation. The best days were in the past. I think the things are going to be, say, would be worse in future. So Lahore Spiti means that transferring the whole infrastructure of apple cultivation to another place, it requires a lot of cost. So adaptation doesn't mean simple adaptation. It requires a lot of costs, infrastructural changes and all those things. So it can be a test case that how apple cultivation is going to affect it and how governments or, say, people are going to respond to that. Some people say that we should go for other fruits, or some people say that why not mango? Mango, which can be grown in, say, mountains, off-season mango, and all kinds of things are being suggested. So my submission is that climate change, the cost normally, we easily say that we should adapt. No, the cost can be quite heavy. So decline in apple, it summarizes that there are many factors which are playing a role. Also, say, economic factors, people who become rich don't want to cultivate apple anymore. They want to do something else. Young people want to leave, say, mountains and go somewhere bigger places to express themselves economically. All these factors are there, but overall, it has some climate change angle. My point is this. Then, say, biologically, this is a prediction-based research that says that there are certain populations of a species called Kharsu oak. It's brown oak, we call sometimes. Then its botanical name is Quercus semicarpula. It is one of the most important oaks. Oak is one of the biggest genera in the world. Some 400 species, 3 species belong to this one genus. So must be among the most important northern hemisphere species. So we have our oaks in Himalaya. Now they occur close to summits, peaks, and they surround the peaks, and then so you can see the distance between two peaks can be 30 kilometers, 40 kilometers. So it's not possible for them to migrate easily from one island to another island, something like that. So what is happening to them, it's quite possible that they would be among the first major species, as we call it, tree species, which used to occur along the entire Himalayan arc of 2,000 kilometers, something like that, is in problem. Then there is other area which is technology which people are using, is they call it say tree ring width analysis in relation to climate change, or you can say tree ring chronology, they call it. Means they measure width and then try to relate it to the temperature, moisture, and all those factors. It's possible to take cores from the stems, and then you have rings there, and then this technique is used by, say, in this Birbal Sahni Institute, some scientists are there who are helping us in this project, and they show that you can always predict that what kind of changes are going to take place in future, because their method is based on finding out correlation between tree ring width and the climate conditions. That clearly again shows that what the research showed was that the pre-monsoon is a critical time. It showed that when pre-monsoon is warmer, then there is a decrease in ring width. But when it is wet as well as warm, then the ring width is higher. So if pre-monsoon is going to be like this as it has been, then we are going to have a more serious impact. But when it is accompanied by rain, then things may be better. We don't know what is going to happen in future. Predictions are that we are going to have more monsoon, but we don't know what is going to happen to season by season. That has become more important, not the annual amount only. We should know about which are the critical periods as far as plants are concerned, or even animals in your case. Pre-monsoon is also a serious issue in the sense that birds also, there are some evidences that they show they are not able to hatch because of shortage of insect population or insect food material. So this is, in this case, I was just trying to show that this Quercus semicarfolia can go up to this point, but not beyond that. Then it has fallen down. It has to. And then this is the area where most of the endemic species occur. Say Himalaya has about, some estimates show that something about 3,400 endemic species, plants. And this is these are the centers of such species. One is that oak can't go beyond this, so it has to, and oak can't jump from one place to other. So perhaps we need to have, say in future, what you call assisted migration science, something like that. We would be needing to really conserve these species. And then these are the, what you call, say, Uttarakhand says Sanjuni sites, means where there are more medicinal plants. So if these species are going to encroach upon, say, alpine meadows, so then alpine meadows would have fewer species. And carbon ecosystem properties also are going to change. These are some timberlines I just want to show. It can be abrupt. It can be, then in many situations, timberline, what we are trying to show is that a timberline is not simply a kind of landmark which shifts in response to warming. There are a series of ecosystems. One of the most important common is a pica, which is quite common in these areas. And then it is, I call it, say, ecologically, you get many physiognomic types. I'm saying when temperature becomes cold, it's not enough to support tree growth. Then you find many kinds of species. You can see some crumholes, means twisted plants or something like that, like rhododendrons, which are stunted because of climate and those factors. Then you have open forest, then meadows and all this. They make at least 4 or 5 or 6 physiognomic types you find in very small area. It should be treated, our approach of studying timberline should be not simply as a landmark indicating the response to climate change, but ecosystem approach functioning, how these physiognomic types are related, interrelated, how animals use them, and how this kind of science needs to be developed. Perhaps it's a very early stage, it is in infancy, but we know that we get many types of ecosystems in very small area. Like this, I'm saying, you have snow, then it has made a finger type of timberline because snow doesn't allow any tree to grow. And say how these fragmented different kinds of communities of physiognomic types are important as far as carbon, biodiversity, and animal roles and those things. We need to understand these things. Like this, I'm saying, this is just to show that here is the juniper mat. It makes a kind of mat on the bottom. And you can see the other aspect is supporting crumholes of rhododendron. I mean, how much diversity in terms of physiognomy is in a very small space. You can't get, say, crumholes on this side, and these are different aspects. One is warmer, the other is cooler. So that kind of diversity is present at timberline. I call it physiognomic diversity. Means that different communities have different shapes and structures. Well, all these years, what we have been seeing that the droughts which climate change can cause can be much more severe than they used to be, people could perceive. For example, water potentials during normal drought used to be about something minus 2 MPa in trees. But in one of the recent droughts in Nainital, which is supposed to get, say, a lot of rain, about 2,500 millimeter, the water potential was minus 5.5, and the trees were started dying. People thought that there's some disease, but it was simply drought. So my point is that such droughts are going to be many more. So climate change is going to change the structures of vegetation also, and maybe the species compositions, all those things. We need to really understand these things. Other thing is that the regeneration. If you look at, say, even India, these are a few things which I wanted to show that seed germination is very critical time as far as regeneration of a species is concerned. And many species has synchronization with the monsoon, means their germination coincides with the arrival of monsoon. They had very short viability. I'm saying they didn't spend energy on on prolonging viability period. They're very short viability. Some are viviparous, means they germinate while on the tree. And there's a relationship between arrival of monsoon and their germination. Now, because of some changes in arrival of, say, monsoon, or maybe seeds may mature first, much earlier than they used to be, you may find that this gets desynchronized. These are, say, examples, some oaks and sal, Shorea robusta, you know, that's one of the most important species of the upper half of India. And they have vivipary as well as synchronization of this kind, a very short viability. So seeds can't germinate after a week if there is no monsoon. And then you have, say, oaks, which are where seed fall takes place during winter. What was happening is that the seeds used to be on the ground. Acorns supported a lot of wildlife, many flying squirrels and all those populations. Now, what is happening that because of drying, more drying and higher pre-monsoon temperature, more evapotranspiration, they get desiccated by the time monsoon comes. And so they used to be on the ground for 4 or 5 months, supporting many animals, many wildlife populations. Now, this kind of species are in problems. Some research, some data clearly show that 99% seeds become desiccated by the time monsoon occurs. Then there can be third type of species like deodars, where seed germination depends on snow melt. So if the snow melt is going to be not available in the future, such species would also be getting some problem. Then fir and some birches, deodars, they are affected by this. So three different kinds of species which Himalaya and much of India have, they are going to be affected simply because of these changes. So we are going to have more conifers perhaps in Himalaya. Some people argue that there should be more broadleaf species than conifers. In that game also, the more pines, more conifers are going to, because they are more desiccation tolerant than broadleaf species. So this was just to show that that the fire intensity and spread of fire depends on the amount of rainfall. If it's low, then there will be more fire. If there is more rainfall during pre-monsoon, then it would be more fire. So pre-monsoon is a critical time from this point of view, not only tourism, not only leaf production, but also in terms of fire. And then say fire means black carbon also, more black carbon, and some concrete researchers show that as far as glacier melt is concerned, black carbon is also a big contributor. Some people believe that about 50% contribution is from black carbon. Black carbon gets deposited on, say, glaciers, and then albedo is reduced, and also it has a direct warming effect. So now it is a question of development now. It comes, it's not only fire which is a source of black carbon. It's all, it's cooking energy also, firewood dependence of people, the poverty issue. Can we justify that last of the people should be given clean cooking energy? Can we say that clean cooking energy should be human right or something like that? Because of, it has also climate and health issues. And the other thing which is important, that the degradation of forests because of dependence on firewood, fodder, and all those things on day-to-day basis. Forests are getting, depleted of carbon. So carbon reservoir is getting depleted simply because of, so can there be justify some interventions like clean cooking energy as a right, fodder and all those developmental interventions are possible. This is the common lifestyle is still in mountains. People say 50% people still pass through this kind of life. We use the word drudgery, means a kind of disintegration of body, not getting enough food to support them. So they become old by 40 or something like that. So this, and then cutting leaves because of from trees means less carbon sequestration and low quality fodder. So things are changing rapidly now because of other reasons, not because of that. But can we do something like this? For example, one small intervention, clean cooking energy at the affordable cost to the poor people. How many things can it lead to? Reduce drudgery, less indoor pollutions, and then enhance child care, women health, and all those factors. If you calculate the cost of, say, this energy, providing clean cooking energy, it can be LPG, it can be hydropower. After all, Himalaya produces a lot of hydropower for Delhi and other states. Why not say, people should be allowed to use that for cooking or something like that. Then the advantages in terms of biodiversity, carbon sequestration, women health, if you can do some good research, calculate all those things and show to the planners that look here, these are the advantages of these things. Perhaps we are moving in that direction. I've been seeing it for last 10 years. And we wrote a draft for Government of India. Government of India is sensitive to this issue. They think that this is supportable or something like that. So the point is that the Himalaya provides a lot of ecosystems. Forests sequester carbon. Women, I think drudgery should be reduced on account of, say, human issues as well as, say, it is something doable. The idea is this. Here I raise the issue that's, I call it, it's just now I'm trying to, say, discuss with people climate change justice. Means globally about, say, per capita CO2 emission from fossil fuel is about 5 tons per person per year. America used to produce about, earlier it was about 20 tons CO2. Now America has reduced substantially in recent years because of clean energy and all those factors. India's per capita CO2 emission is ridiculously low, I call it, because we say that we are doing very well economically. I sometimes doubt your CO2 fossil fuel emission doesn't show that. Either you are doing some kind of jugglery in data, or it's not, you are not economically doing well. I'm very clear about these things. Only one can be correct. Your India's CO2 per capita CO2 emission is less than 2, about 1.5, 1.6, 1.7, some data. It depends on the kind of calculations you make. In Himalaya, it should not be more than 0.5. I'm saying they are the lowest emitter, but look at the sufferings they have, the people in Himalaya get because of calamities and all those, because of climate change. We need to really develop some indices about this thing. Say, suffering in terms of disasters, suffering in terms of the uncertainty of agriculture, suffering in terms of road blockades, say how many days you have your roads are blocked and how many days you are remain in uncertainty. All those factors, if you calculate all those things, I'm saying you need a different kind of social science. Then a ratio can be calculated. I'm sure that Himalayan people suffer most, I think, that way. They emit least, but they suffer most. Perhaps maybe coastal areas are going to find this kind of problem in this part of the world. So we need, it's not a question of, say, at global level. Even at regional level, these things should be, the justice issue should come. Equity issue should be really taken seriously. It's simply, I try to show that it should be something like that. Don't believe these data. Himalaya situation would be per capita fossil fuel CO2 emission here, but the climate change impact should be several times more. Delhi would be somewhere here, more emission and then some suffering. It's just to show that how things differ. My point is that how to really support this kind of thing. I would say, let's say, for example, constructing a road in Himalaya costs something more than normal roads. So you should, I'm saying, these things should be justified on account of these factors. I'm a provider of ecosystem services, sequester of carbon, and providing hydroelectricity so that Delhi has a better carbon budget. All these services we include. I think there's a justification that the higher cost of things should be supported, and so that there's a less damage to roads or less. Or suppose you have There's a region, there are two regions, Ravi knows that Kumayu and Garhwal, there's a road through forest. It's not allowed simply because animals, wildlife animals may be affected. So can we support something like about 20 to 30 feet high columns, road, and the cost will be very high. So the animals also survive, they can move, as well as the roads are there so that CO2 emissions and all those things are reduced. So that kind of support can be justified on these factors. Perhaps this is an area which needs to be, worked out, better research is required, and calculations are there, more better calculations are made. So I think it's over. I'm really happy that I could communicate, I could talk to you, with you. And because the future is yours, and remember that the world would be very different if you really value science. Otherwise, the faith would deciding most of the things, and that would be, say, something medieval time behavior. So please keep in mind and do science, make more people interested. It's sad to know that people from Dehradun are not many here. We need to really, I'm willing to contribute to those things.
Lady here, right here from there.
She smiled when I came here in the room, but perhaps she recognized me, I remember. But the point is that, say, we need to really join hands. And say, if you are a different person, then India would be certainly different, not the way India is being managed. I'm not really very happy about those things. So science should be given support. Then the world would be far better than it is. Science doesn't mean simply doing science, it means also temperament, spirit, culture, and all those things. Thank you so much.